Okay, so. Jetzt hoffe ich, dass Sie alle sich gestärkt haben, viele Erlebnisse schon mitgenommen haben auf der Teststrecke und hier im Labor. Ich darf Sie begrüßen zur zweiten Runde, zur Nachmittagssession. Das Thema Testeffizienz. Wir wollen jetzt die Brücke schaffen zwischen dem Thema Simulation und Testen und haben deswegen auch etliche Vorträge, die darstellen, wie man diese Brücke schließen kann. Sie haben ja auch schon einige Techniken dort wahrgenommen oder vielleicht erlebt. Wenn nicht, können Sie das in der Nachmittagssession dann auf der Teststrecke oder dann in den entsprechenden Ständen nochmal machen. Deswegen würde ich eigentlich gleich in Medias Res gehen und den Adrian Sims begrüßen. Mikrofon, already Mikro. Und er wird uns zum Thema von ABD, er wird uns zu dem Thema auch Technologien zeigen, wie man Simulator auch mit Testen verbinden kann. Adrian, stage is yours.
Well, thank you for the introduction, Professor Schick. Good afternoon, everyone, and welcome, and thank you for joining us today. So, whilst achieving virtual sign-off by 2024 may seem ambitious, it's an aspiration of many. The reason for this is because the automotive industry is facing unprecedented challenges. This includes the necessity to reduce costs against the backdrop of electrification and increasing cost, ever-increasing number of NCAP tests that need to be performed on the track, causing challenges with proving ground availability. All of this is before you even consider the impact of autonomous vehicle development. So whether virtual sign-off is achieved by 2024 or when is open to debate, but there's clearly a significant demand to increase the amount of testing in the virtual world to accelerate vehicle development and to reduce costs. So as a group of companies, AB Dynamics aim to facilitate vehicle development for activities that span the entirety of the product development V-cycle. This goes from the top left corner, which is from simulation, all the way to testing in the real world, whether it be on the proving ground or on public roads. By leveraging the group capabilities, we can deploy a consistent software toolchain for virtual testing and for real-world testing, with the objective of reducing the gap between the real world and the virtual world to improve correlation and to facilitate verification. The schematic at the bottom of the slide is intended to highlight the benefits for ADAS development. So the left image shows the high fidelity and high immersive environment where the majority of virtual testing takes place. This also extends to driver-in-the-loop simulation for specific applications. Virtual NCAP testing provides a great way to reduce the gap between the virtual world and the real world. In this situation, ADAS systems are finally verified on the proving ground using our range of soft-bodied vehicles, so our guided soft target and launchpad, again using the same control software as we can use in the virtual world to really bring the two worlds together and make life simple. As per the previous slide, our toolchain is equally valid for classic applications, such as vehicle ride or vehicle handling. The subtle difference in this situation is that in this case, it is a highly accurate model of the real world, including the high-fidelity terrain. It could be a model proving ground, for example, which provides a tight link between simulation, driver-in-the-loop simulation, and the real world. So, because we've got limited time today for the presentation, unfortunately, it's not going to be possible to go into a great deal of detail technically about the toolchain, but what I will say is if anyone's interested, please come and join us on the first floor later on today, where we've got an AB Dynamics workshop and a team of experts who would love to come along and talk to you about this in more detail. Coming back to essentially an overview of the toolchain, it starts off with our scenario generator software. This is used to define the paths and speed profile of all the actors in a scene, so it could be as simple as 2 vehicles for a simple NCAP scenario, or it could go up to many, many vehicles. Where it gets more clever is where we use our patented synchro software. This is at the heart of our toolchain, and this is a software that is used to synchronize all of these vehicles or objects in the virtual world and the real world. And one of the key features really is it's got the ability to correct for small errors. So for example, if the the driver of the ego vehicle is driving laterally offset from the command profile or at the different speed profile, all of the vehicles in the scene or objects will automatically resynchronize to try to maintain the scenario that you programmed and not a scenario which is different. On the next slide, I can show you a few examples of ADAS simulation which have been deployed using this toolchain. So on the left, the first example is a synchro intersection where a car cuts across. The second one is slightly more complex, where we've now got 3 vehicles, and roadworks are causing a vehicle to cut in front of another car, causing an A/B test to be triggered. So the high fidelity and highly immersive visual environment is clearly very important for the driver in the loop application, but it's perhaps more so important for feeding sensor models. So within the virtual world, it's possible to position sensors all around the ego vehicle, whether it be camera, LiDAR, etc. And all of these are capturing the high frequency physics of the vehicle. So as the vehicle moves, as it goes over the accurately rendered terrain, so do the sensors. So really, it gives you a great way of feeding your perception system with the highest fidelity data. This, for example, could include a LiDAR sensor model. So the one we're showing here is a Velodyne LiDAR sensor that's prepared by our partner Claytex, and the output of the sensor model can be viewed in the Velodyne VeloView software exactly the same way the real-world sensor would be viewed. Some other examples of way this data can be used is for hardware in the loop testing. So there's an example here is a camera box in the loop with a D-Space Galexio controller. This is some work we did with one of our partners in China, Qatar, the test house. And another example, again, at Qatar is a radar over the air. So there's a real radar on the test included in the loop to exercise a simulation. So here's just a very, next slide please, Dave. I've got a very simple video here of an AEB car scenario, which is using a virtual, one too far. Thank you. Yeah, so it's using a virtual model of our guided soft target, the GST, with a soft car 360 target on top of it. So we can perform a full set of, or a full suite of NCAP tests too. And as mentioned before, maybe a bit of repetition is, all of these are controlled by our Synchro software, providing the link to the Proving Ground test. And you can see the software on the right-hand side. So if you've got any users of AB Dynamics track test products, that's software that you should all be very familiar with. Or people who've seen it on the Proving Ground this morning, perhaps. We have a comprehensive range of soft targets rendered in RF Pro. So this includes vulnerable road users, so the child pedestrian, the adult pedestrian. We've got a child cyclist, adult cyclist, moped, motorcycle, and GST. Once you've run the full suite of NCAP tests, you can use the AB Dynamics post-processing tool to evaluate the test results against the requirements of NCAP. This post-processing is designed to conform to the post-processing requirements of NCAP and gives a simple pass-fail result, which can also be output as a printed report. So once you start using Driver in the Loop, a great application is acceptance of ADAS functions. These can be performed on our full suite of simulators from static all the way up to dynamic. A good example is lane keeping assist. Obviously with the Driver in the Loop, it's very easy to start getting subjective feedback on the performance of these systems. But if you start to introduce driver monitoring, for example, heart rate monitoring, gaze detection, pupil dilation, galvanic skin response, you can start to also measure the driver acceptance of these systems in an objective way too. So most of you will have probably seen the AVDS here. That's our dynamic simulator, and it's got a high frequency response and low latency motion platform. This extends the range of ADAS scenarios beyond what you can do on a static simulator significantly. So you can start looking at ADAS scenarios that incorporate dynamic events such as AEB, for one example. As a general comment about our software toolchain for the Driver in the Loop simulators, we've deliberately gone for a very flexible and open architecture, which means that users can come along with any vehicle model and tyre model combination that work together. on whatever real-time system they will run on, and they can instantly incorporate those into our tool chain. So it gives the users flexibility to get on with their development work easily. The example shown here that's now finished is showing an IPG car maker vehicle model and sensor models, but the visuals that you can see on the actual projection system itself are our sister company RF Pro. So the high performance of the AVDS makes it extremely well suited to the ride and handling applications, as have been demonstrated here today by Bernard and his team. For these applications, a key requirement is to be able to develop vehicles by being able to make extremely small parameter changes and for them to feel representative and accurate. We had a really nice quote from Ian Wright, the head of vehicle science at Alfa Romeo Racing, who stated that the AVDS has a unique capability where every single parameter change we wanted to make was detected by our driver. So on the early slides, we've covered some very simple NCAP scenarios. Over recent years, German OEMs have been pushing the boundaries significantly, so instead of just having one or two actors in a scene, they've been going up to highly complex highway scenarios, including many, many vehicles, maybe 9, 10 vehicles in total. So this is where having this tool chain where you can perform the testing in exactly the same way in the virtual world as the real world really starts adding extra benefits. And this clip we're showing here is one such example of a highway scenario. And we've spliced together virtual and real in the same clip. Right, thank you all very much for listening. As I mentioned earlier, if you'd like to come and learn how we can help you accelerate your vehicle development, please come and visit us on the workshop on the first floor. Thank you again. Thank you.
Thank you, Adrian. I think it must be cool to drive a Formula One with sunglasses and maybe without helmet. No? I think this looks cool.